What is quantum chemistry? Quantum chemistry is like the rule book for atoms and molecules. It uses ideas from quantum physics to explain how tiny particles like electrons behave inside atoms. Instead of imagining electrons as little balls flying around, quantum chemistry says they behave like waves and have strange rules. So why is quantum chemistry important? Because it helps us understand why atoms bond, what makes molecules stable, how light interacts with matter, and why some materials are magnetic or glow in the dark. Basically, it explains the why behind the things we see in chemistry. So there are some concepts that we should be able to grasp when dealing with quantum chemistry. We have the wave-particle duality. This is where tiny particles like electrons behave both like particles and waves. The uncertainty principle. We can't know exactly where an electron is and how fast it's going at the same time. Quantization. Electrons can only exist in certain allowed energy levels. They can jump between them but not hang out in between. Orbitals. There are regions in atoms where electrons are most likely to be found. Think of them like electron clouds. Electrons spin. Every electron spins like a top, and this helps explain how they fill orbitals. Now the Schrödinger equation. This is the heart of quantum chemistry. This is like the golden formula in quantum chemistry. It helps us predict where electrons are and how they behave. Atomic orbitals and quantum numbers. Electrons live in orbitals, which have special names and shapes. S orbitals, sphere-shaped. P orbitals, dumbbell-shaped. D and F orbitals, they have more complex shapes. Each orbital is defined by quantum numbers, like a unique address for every electron. Principal, quantum number n, and it's an energy level like floor numbers. Angular, quantum number L, shape of the orbital. Magnetic, quantum number M, and orientation in space. And then spin, represented by S, is the direction of spin, up or down. The periodic table and electronic configurations. Quantum chemistry helps us understand the periodic table. Electrons fill orbitals in a specific order. This is the Aufbau principle. No two electrons can have the same exact set of quantum numbers. This is the Pauli's exclusion principle. And electrons prefer to occupy different orbitals before pairing up. This is the Hund's rule. This is why elements behave the way they do. Chemical bonding. Why do atoms stick together? Covalent bonding. Atoms share electrons. Ionic bonding. One atom gives away electrons to another, like donating. Metallic bonding. Electrons float freely among atoms, like a sea of delocalized electrons. Quantum chemistry helps explain the strength, shape, and angle of these bonds. Molecular orbitals. When atoms bond, their atomic orbitals mix to form molecular orbitals. Bonding orbitals. Lower energy, more stable. Antibonding orbitals. High energy, less stable. This helps us predict if a molecule will form and how strong the bond will be. Spectroscopy. Molecules and light. Spectroscopy is like giving molecules a flashlight and seeing how they react. UV spectroscopy. Electrons jump to higher energy levels. Infrared. Molecules vibrate. Nuclear magnetic resonance. Atoms spin in magnetic fields. Each method tells us something about the structure of molecules. Now, approximation methods. Solving quantum equations exactly is super hard, so scientists use clever shortcuts. The Born-Oppenheimer approximation. This is the approximation that separates motion of electrons and nuclei. Hartree-Fock. It treats electrons individually but includes their repulsions. Density functional theory. It focuses on electron density instead of wave functions. These methods help us study real molecules using computers. Applications of quantum chemistry: designing new drugs and materials, understanding how enzymes work, creating better solar panels and batteries, explaining chemical colors, smells, and reactions. Thank you.